So now for antiderivative, lowercase g, uppercase g, which function prime is 7e to t? It's just 7e to t. Now minus, which function prime is this constant? It's e to the third times t, plus a constant c. And you can say, stop, show me. Excellent. When I differentiate this, I get this. When I differentiate this, I get this. When I differentiate this, I get 0. Is this okay?
Yeah, that makes sense.
Perfect. Okay. Anything?
And is there like a specific like formula that you're using for that, or is it just kind of known? You know, like is it just kind of like you just gotta kind of know?
Which of these three are you talking about?
I just mean like in general for like, is there something that we should do like a formula, like a process that we should do mentally when we're doing this, or is it just something that we should like kind of just be able to do?
Based on the differentiation rules and different functions we looked at, I'm asking myself which function prime is e to t. It can only be e to t. In the next step, I'm asking myself which function prime is a constant. If the constant is e to 3 to the third power, then I have to have e to the third power times t. I'm asking myself which function prime is 0, only a constant. Is that better?
Yeah, that makes sense.
Okay. Any questions, please ask anytime.
Yeah, I have a quick question.
Yes, please. Yes.
A little silly. What is the derivative of e to the third?
We're not asked to determine. That's why I was saying it's confusing. I'm not asked to differentiate e to the third. I'm asked to find a function whose derivative is negative e to the third.
Right.
And
my question is, I always thought e to a power was e to a power as a derivative, so I would have guessed.
But this is not a function.
Oh, okay.
The function has t in it. This term does not have t in it.
Okay. Thank you.
If it did, so let me make up another situation here. So let's say I have f of x, which is 7e to t minus e to the third t. Then the antiderivative, uppercase f of x, will be 7e to t minus e to the third t squared over 2 plus a constant c. When I differentiate this, I get that. When I differentiate this, I bring the power down, simplify, and I get that. And when I differentiate c, I get 0. So e to 3 is not a function.
Right, that's just a number. Yes, okay.
I could say it's a function because it's y equals e to the third is a horizontal line. So maybe this is not correct to say it's not a function. It is a function. It's a horizontal line, but it doesn't have a variable in it.
Right. Okay.
That's what I meant. So maybe I shouldn't write is not a function, but I would write it's just y equals e. I already wrote it there, e to the third. So this is a constant. It's a horizontal line. That's what I said. We have to discuss these things, and it takes time because it can get confusing. Good. So let's choose anything else. Now we have here, for example, find the antiderivative uppercase f of f that satisfies the given condition. When we are given a given condition, when we are given the initial condition, then we will not determine a family of functions, but a specific one type and one function. 27. So we have f of x equals 2e to x plus 6x, and we are told that the antiderivative at 0 is 1. This is specifically given to us to identify the constant and determine only one, a unique function. Okay, so uppercase f of x I know it's going to be 2e to the x plus 6x squared over 2. So add 1 to the power and divide by the same number, plus a constant c. Of course, I will simplify. I will write it again. 2e to the x plus 3x squared plus a constant c. And now this condition says that this piece is 1 when x is 0. When x is 0, 2 times e to 0 will be 2. This will be 0, and this will be plus c. So when I subtract 2, I get that c equals -1. And this comes from the given condition. And if that's the case, then now I can write a unique function, not a family of functions. Only one function whose derivative is this and satisfies this condition at the same time. And there is no other. So our initial discussion was the derivative, the differential, and the antiderivative. They all mean different things. The most general antiderivative is this. And the specific one, given an initial condition, for example, is this. We are given the derivative, so if you differentiate, you will still get that. But this is the only function in which if you plug in 0, you will get 1. No other function that has the same derivative and fulfills the given condition. So these are the two types of antiderivatives. Now, we are moving on into a slightly different territory. And I will explain in a minute what I mean by that. All these problems were giving us the function, lowercase. Now they're giving us the second derivative, maybe the third derivative, maybe the first derivative. The notation will be different. And you can say, what's such a big deal about it? I will explain in chapter 5 why the notation is so important. Okay, so now let's choose anything you like. So I'll go slowly, or you, if you have your book open, you can choose yourselves and tell me what you would like to start with.
Can we start with 30?
Let's start with 30. Good one. So we have the second derivative of t equals t squared minus 4. Perfect pick. Okay. They're asking us to find the most general, I didn't need to put a dot in there. Here I wanted to put the dot. The most general antiderivative. Okay. So I am given the second derivative. Can I jump to the function directly?
No.
No. What do we have to determine first? In order to get to the function, what do I need to determine first?
The first derivative.
Exactly. I need f prime first. Now, let's try to get used to this. What function prime is t squared?
1/3 t cubed.
Yes. Minus, what function prime is 4?
4t.
Plus, what function prime is 0? Now I say it's a function, so it's a constant. So it's a function. Okay. Okay, perfect. We have not arrived yet. We determined f prime. But we want to determine f. So notice that once f prime or double prime is given, we have to stick with the notation f. We're not going to change to uppercase f. When we're given, so for now, just remember that. So when we are given f of x, we must use this notation. Of course, if I'm given g of t, I have to use this notation. But if I'm given f prime or double prime, I have to stick with lowercase f. So finally, we are arriving to f of t. Indeed, 1/3 has to stay in front now. which function prime is t cubed?
One-third t or t to the fourth over 4.
You mean t to the fourth over 4 minus
Yeah.
4. Perfect. Which function prime is t?
T squared over 2.
Perfect. Plus, which function prime is c?
T?
But ct
Oh, sure.
plus. You can say, I don't like c and d. Fine. In that case, I will denote this by c1 and this by c2. It doesn't matter. It's up to you. But they have to be two different constants. So you either stick with c1 and then c2, or you just use c and d. This is the most general antiderivative. Yes, it needs a little bit of simplification. So f of t will be 1 over 12 t to the fourth minus 2 t squared plus ct plus d. What does this represent? It's the most general antiderivative, whose second derivative is this. If you differentiate this the first time, you will get that. And if you differentiate this, you will recover t squared minus 4, guaranteed. Any questions? Okay. Do we want to choose something else?
Excuse me, could you go back one more time
Yes.
and talk about how you got from t to the third power over 3 to 1/3 t to the fourth power over 4?
So this function prime is t cubed. The 1/3 stays in front.
Okay.
So t to the third over 3 can be rewritten as 1/3 t to the third. And this function prime is t to the third. Bring 4 down, simplify, and subtract 1 from the power.
Oh, okay. Okay, now I get that. That makes a lot of sense, actually. Thank you.
Great. Other questions here? Would you like to choose anything else? Yes, I would like to choose 39. I keep choosing, so get ready and choose next time. 39. So we're given the first derivative of t as 4 over 1 plus t squared, and they are giving us f of 1 equals 0. That's the initial condition. Okay, so obviously at this point, they're not asking us to find the most general antiderivative. No, they're asking us to find the specific antiderivative, which, because we have f prime, we have to use the notation f of t. And it's going to be a unique function whose derivative is this and fulfills this condition. But first, we have to find the most general antiderivative. So let's find the most general antiderivative first. Can anyone tell us what function prime is 1 over 1 plus t squared? It's a super important function. We talked about it many, many times. We even graphed it many times.
Is that arctangent?
Thank you very much. So this is the most general antiderivative, but since we have this condition, this will enable us to find c. It says that f of 1 is 0, 0 when I plug in 1 in here. So 4 arctangent 1 plus c. Now we have to discover or remember what angle has tangent 1, because I have to replace this by that angle.
5/4 and 5/5.
Very good. So it's, very good point you're raising. So for arctangent, the domain is this. Between,
right, I forgot.
between negative pi over 2 and pi over 2 for the arctangent. So this is the domain. So it can only be pi over 4. Nothing in the second or third. So pi over 4 times pi over 4 times 4 is pi. So then c equals negative pi. So then f of t equals 4 arctangent t minus pi. This is the unique one function whose derivative is this and passes through this point. What point? 1, 0. When t is 1, y is 0. It's the only function and no other. What is going on? Why is this not... Okay. Good. Have you chosen, or I will? Okay, I'm going to choose 49.
Can we
Yes?
can
Yes?
we do something with division?
Yes. Yes. So 49, and then please choose one, and then after that we'll do the division. Okay, let's take a look. So let's take a look at the division. A division. You meant something like this? Or you meant something like this? Which one?
The first one.
18?
Yeah.
Okay. So 49 and then 18. Let me copy both. So f of x equals 5x squared minus 6x plus 4 over x squared. Of course, x has to be greater than 0 because it cannot be 0. And the 49 that I picked, where is 49? We have the second derivative equals 4 plus 6x plus 24x squared. F of 0 is 3, and f of 1 is 10. Let me see the time here.